me. Just sometimes what happens is uh, when we were participants in different seminars or workshops like this, we also always had a curiosity to know the resource person a little bit more about his activities and things, what he does, and all those things. So, just to add few lines with Darshankar. So, I am teaching here in the Department of Statistics, Vishwabharati, since 2008, and before that, I was in a college, Nindapur College, under Vidyasagar University. And meanwhile, I have been to US for my postdoctoral work. There, I worked on real-time tropical storm forecasting, and this is my technical, background. And then I am by professional training. I am a statistician, and I did my master's, PhD, and BSc all in statistics. I have a special interest on application of technologies in teaching. So I am very much indulged in applying LMS, developing LMS, and introducing those in various aspects. So, which we started long back since 2018, not after the COVID. It's pre-COVID scenario. We started all these things. In fact, in this particular center where you are taking part in this workshop, there we arranged one physical workshop back in 2019 on online learning, how to practice all those things. So I have a special inclination to work on these fields as well. So right now, today, our topic of discussion is not that thing. We are we are supposed to discuss SPSS and topics. They are like correlation and regression in this regard. So before we start, I would like to ask few of you that how many of you actually use SPSS, so that I can have an idea that what level I should start with. Means many people uses it uh, for 4 5 years. Many have not used it at all. Maybe they are just getting introduced to this software just now, and so I have these experiences from different workshops. In fact, I also arranged in a single year probably 6 workshops on SPSS in the same center. So from there also we have this experience. So before we start the session, technically the academic discussion, just I would like to have a quick response from your end so that I can know how many of you actually use SPSS, and how far, means how frequently you use it, and what is the extent of it. Very, in 2 3 words, if you say. Please go ahead. I would like to start from uh, so Abhishek Tripathi. Can you please
Yes,
mention yours?
sir, I'm using SPSS from the last 7 years, 7 to 8 years I'm using.
Okay, so I assume you are an advanced user of SPSS. So anything else
Yes.
do you use other than
Yes,
SPSS?
MOS and SEM.
I'm sorry, I couldn't get that one.
MOS and SEM, structure equation, PLS.
Okay, okay, okay. I got it now. So do you use any open source software other than
No,
SPSS?
no, sir.
Though SPSS is not an open source.
Yes, no, sir. Only these three.
Oh, okay. Okay, next, Amartya. Probably, I think you are known to me. Yeah, Amartya, are you there, Amartya? So probably he is not joined with the audio because I don't see the audio icon from his side. Anyway, so let us move to the next one. Rahul Misra.
Hello, sir.
Yeah, go ahead.
Sir, I'm using SPSS. I mean, from 2020-21.
Yes.
Since my research is in the population studies, so I
Okay.
have to use this software very keenly. Other than this, I am not using any kind of statistical software, but I'm planning to jump into Stata and R in after some time.
Okay, good to hear that. Now, Trupti Jadab. So I guess we are not getting any response now. Sonali Shardar. Hello, Sonali Shardar, are you there? Probably not. Then Tushar Kanti Haldar. Can you hear me, Tushar? No response. Now, Preeti Patel.
Sir, I have been using this SPSS since last 1 year.
Okay, so
Last
you are
1 year I'm
also
using.
bit habituated in that. So any other software do you use?
No, sir. Only this SPSS and
May
a
I know?
bit of a mouse, but very. Yes, sir.
Hello,
Okay, may I know your
Yes, sir.
background?
hello.
Sir, I'm senior research fellow in Department of Commerce, Calcutta University.
Okay, in commerce. Okay.
Yes.
Okay, Tushar, please go ahead. Tushar, we were hearing you, but we were in between in the conversation with PT Patel. That's why I could not take your call. Please go ahead. I feel there is an technical issue. Now, Manojit Gorai. Then Mugdha Mohini.
Yes, sir. Good afternoon. Sir, I've
Yeah,
been
very
using SPSS since the last 1 month. Since it's new to me and I'm not very much accustomed to using it, but I'm actually learning it right now. So that's the purpose I've joined this workshop also. Since
oh.
I have not used any of the software, but I have just started using SPSS.
So in no other software you used for statistical analysis,
Mm,
right?
No, sir, no, sir. Actually, I was just in the data collection process. So right now I've done it. So now I have to analyze it. So I'm learning it better
Okay.
now.
May I know your subject?
So I'm from economics. My course which is economics, and I am a research scholar at Department of Humanities and Social Sciences, NIT Patna.
Okay, very good. Then Unnati Ubnare, if I'm pronouncing it right. Unnati Ubnare. So no response. Then yeah, Tushar, go ahead, please.
At that time, I could not connect the phone, sir. For that reason, I couldn't reply. I have
Right.
recently used SPSS, sir, but very much beginners level. Just I have
Okay.
done T-test and ANOVA only, but
Okay.
without
Okay.
having much knowledge, sir.
Okay. No problem. Thank you very much for your information update. Then Shukla Devnath. Are you hearing us, Shukla? Then Parangama, probably Parangama Chaudhary or something. I'm not getting the
Yes,
whole name.
sir. Good afternoon. Sir, I am using SPSS from last 2 years.
Okay.
My area of research is urban demography. I am from the subject geography in Department of Geography, University of North Bengal.
Okay. Thank you very much.
Yes, sir.
Then Dr. U.S. Chauhan, are you there?
Sir, good afternoon, sir.
Good afternoon.
Sir, I am first time using SPSS.
Okay. So have you used any other software for statistical analysis?
No, sir, no, sir.
Okay. Then Sujata Day.
Good afternoon, sir.
Very good
I
afternoon.
do, I do not have any prior exposure to SPSS, but I will need it for data analysis for my PhD. Currently, I'm pursuing PhD from ICRC Free Barakpur as a CSIR Senior Research Fellow in metagenomics of identification and plastic degrading microbiota from plastic wastes.
Okay, so you are from biology background, probably.
Yes, sir. Yes, sir.
Okay, okay. Then thank you very much. Then Sneha Agarwal.
Yes, good afternoon, sir. So I've been
Mm-hmm.
using SPSS since 2 years, but very basic features, sir. I just know about few non-parametric tests. So I have actually joined this workshop to increase and enhance my knowledge on SPSS, sir, because I need it for my research.
Okay, so may I know your subject, please?
So management.
Okay, you are from management. Okay, thank you very much. Then Rajeshwari Dash
Good,
and then
Das Gupta, sorry. Good afternoon, sir.
Mhm.
I have never used SPSS before. I've just started my PhD at the Department of International Relations in Jadavpur University. But I've never used SPSS before.
Any other software?
No, sir. I mean, I've just started writing my research proposal properly. So now I'll be gathering data. So I would like to have the option to analyze it in this way. That is why I've joined you.
Okay, okay. Good to hear that. Naga Krishna, the last part I cannot see. Okay, so Naga Krishna did not speak, and he said in the message, and he said that no, sir, started learning, no other software used. Okay, thank you for your information. And probably he is having some network issue, that's why he did not speak. And okay, and then okay, thank you, Naga. Monojit Gorai, did I hear you? Probably yes.
Yes, sir. Good afternoon, sir. Sir, I
Mhm.
never used SPS practically, but attended various workshop on SPSS, but never practice it in practically.
So, which subject are you from?
I am from social work background.
Okay. So, anything, any other software you use other than
No,
SPSS? Though
no,
you
sir.
have.
No, no, sir. No, sir.
Okay. Thank you. Durga Na.
हेलो सर, गुड आफ्टरनून।
Mhm.
सर मैंने अभी तक कोई एसपीसी सॉफ्टवेयर नहीं यूज़ किया। एक्चुअली आई एम ए स्टूडेंट ऑफ फोर्थ सेम ज्योग्राफी, तो मेरा डिसर्टेशन काम के लिए मैं एक सॉफ्टवेयर सीखना चाहती हूँ।
Okay. So,
थैंक यू
you're
सर।
from geography. Okay.
हाँ, ज्योग्राफी।
Thank you. And then I think that's the last, no, but not the least, Vishal Mudaliar. Vishal Mudaliar. Are you there?
Hello.
Yeah.
Hello.
Please go ahead.
Hello.
Yeah, we can hear you. Please.
Can you hear me, sir?
Yeah, please.
Good afternoon, sir. Sir, I have very basic knowledge of SPSS. As far as this analytical software is concerned, I just use a bit of Excel. Okay. That's it. Not much, sir.
Yeah, very good. In fact, in Excel also, some excellent work can be done. That is also very powerful software. Okay, now
Yes, yes.
Sonali.
So in Excel, like, we can easily find the mean, median, mode, standard deviation, and all those things, like, and can make use of all those charts and all.
Okay, thank you very much, Vishal. What is your background? May I know?
I'm doing my research in
Sorry, I couldn't hear you. You can write your subject if
Hello.
you can in the message. Yeah.
Hello. Yes, sir.
Yeah, I can, but it's breaking. So please tell the subject.
Yes, sir. I'm from Ghosh back, and I'm doing my research on marketing, sir.
Okay, so I assume you are from management. Okay, thank you. And I see Sonali Shardar is writing, due to network problem, I cannot talk. I have no experience about SPSS. It's my first time to learn it. Okay, thank you, Sonali. And Shukla Devnath is also saying, so you see has used, I have used it 2-3 times. Okay, thank you. And I see, did I miss anyone? Probably I missed Shomrita Sinha. Can
Yes,
you
sir.
hear me?
Yes, sir.
Yeah, please.
I am the PhD research scholar in Raja Narendralal Khan Women's College. My background is geography. एंड मैंने थोड़ा बहुत सीखा था, हमारे जब कोर्स वर्क का क्लास होता था तो थोड़ा बहुत एप्लीकेशन हमने किया था तभी SPSS. Yes,
So now you don't use it in normal course, right?
नो सर, थोड़ा बहुत सीखा था बट एप्लीकेशन बहुत कम किया था.
Okay, okay. Yeah, actually we use it when we need, and in all cases it is there. It could be software and any other tool, so there is nothing wrong in it. When we need, we use anything. I guess I covered everybody, and actually I wanted to know how many of you had the exposure of SPSS and how many you are the very new at the beginning level, so that we can accordingly design our talk on that. So I feel since at least 4 or 5 people are there who never used it, so I think I should take care of them and try to let you know the thing from the beginner's point of view. And so those who are using it, for them it will be revision, and to sometimes it may be boring as well. I'm sorry about that. And but those who are learning for the first time, for them I would say this will be definitely beneficial. Number one. Number two is, what my experience says, that most of the time what happens is we get calls and questions from various participants even after the workshop or any other seminar is over, mainly from social science background, that they collect data and then they say with a typical sentence that we have to do some statistics out of this data so that the thesis or the paper should be in a good shape. Now when I ask them that what type of analysis are you meaning to that, I mean what exactly your objective is, then I'm sorry to mention that it gets unanswered. They said, okay, some ANOVA, some t-test, some f-test, and please do, and then we incorporate that in the thing. So that is where I find the problem lies. It is not the software what you are using, whether R, SPSS, Minitab, or whatever data, whatever you are using. It is ultimately the objective of your work, which should be clearly understood by you, and then you can find what analysis you are supposed to carry out. And then the second part is how to carry out that analysis. Okay, so in that way, I would like to present today's lecture in a introductory type, so that we should first learn what we can do with the data, what type of questions we can answer with, and then how to answer all those. And then initially, as I have mentioned, today we are going to discuss with correlation and regression specifically. We shall cover that one also. And in between, if you feel anywhere to stop me or interrupt me to ask any question, please feel free to do that, so that in that case I would understand that you are taking kind of very interest of the topic. Otherwise it will be kind of monologue, as if I am just going to uh, present the thing. And since it is online, so it is very difficult to see anybody's face, and without looking at the face also it is not possible to understand what people can follow or whether they are following it or not. Okay, so let us start with these introduction, and if you have any okay, let me do this one. I think there should not be. And if you have anything to say before I start, then you can please go ahead. Now I'm sharing my screen. Please let me know whether you can see it or not.
Yes, sir.
Yes, sir.
Okay. So I guess there is some question. Okay. Okay, so as I mentioned that, let us start from this one. So initially we can say it like this: understanding and application of SPSS. So basically, why did we come to this particular software? Because most of us do some research or have some question in mind, and we would like to answer those questions on the basis of data, because when something is defended or established through data, then that is more acceptable than just postulating something. Now, generally, what we follow as sequence in research is we define a problem and review that and formulate that, and then collect data and analyze it, and then interpret and report it. That's basically a very crude way to write down the steps of research. Now, what we assume that the data are collected and analyzed using statistical principles. Now, any analysis can be carried out using calculator, if you can, using any software like SPSS, Minitab, R, Python, whatever you are comfortable with. But the very interesting question, what we missed before during the during our study, is that basically what type of analysis we can carry out. Okay, so we have to concentrate on that first. As I was mentioning, these issue which we very often come across from the research scholars as well as other researchers. Firstly, we can answer a question like what has happened. We have a data set, and then we can describe the data set which will answer to the question what has happened. Like if we are here 25 people, and if we are interested in knowing the average income, average monthly income of all of us, then what we would do, we would collect the data of the observation of monthly income from all of us, and then we'll compute the mean, and then we can answer this question that this is the average income per month of these participants. Okay, and then there are other things like median, mode, and each and every of these measures has something to interpret, so which we know. So this thing is very much important. If you have in your mind this question, what has happened, then we should go by descriptive analytics. It could be graphical as well, so which we perhaps know. And then sorry, okay. Then what will happen? The next question comes in our mind. There is no order actually. I just arrange them in my own way. Then there could be a question like what will happen? So that would be answered by predictive analytics. Means if you are going to predict something, like you have 50 years data of crop production, predict production, then what will be the production in next 5 years? If your question is like that, then you can carry out a predictive analytics, and predictive analytics can be done through regression, time series analysis, logistic regression, and many more techniques like this. Okay, so this is another question we might be having. Then, is a given statement true? Or if this is the question you are trying to answer, then we fall that we keep that in the inferential analytics. Then specifically hypothesis testing and estimation. Like estimating means if you do not know a value, it is not prediction. we do not know what is the literacy rate of Birbhum district. We wish to estimate that. Then we would collect some observations and we'll have the proportion of literate persons, and from there we would be saying that this is the proportion, and how that proportion should be computed, how, whether it is unbiased or not, those are actually answered through statistical principles. So estimation and testing of hypothesis are the types of studies which we should carry out if we have to answer some inferential questions. Okay, then maybe we would be interested in how is it organized, that is diagnostic analytics. For example, customer segmentation, clustering are such kind of analytics. Now let me give you one example. Like when you do online shopping, you get into websites of e-commerce houses like Amazon or Flipkart or stuff like that. There you don't get the list of the commodities, but you get some clusters like electronics items, like pantry items, like clothing. Even if within the clothing there are 3 segments at least, like boys, girls, and then ladies. And even within a particular segment there are again segmentations like casual wear, and then night wear, and then office wear, stuff like that. So that means we know what we buy from shop, but how people categorize them, that if it is your kind of question, means you have the data and you are trying to find that how it is organized, then it is diagnostic analytics. Okay, that could be one type of study you may be interested in. Now another thing is anomaly detection. Means, is it weird? Let me give you one more example. Like nowadays almost all of us use credit cards. Now what happens is, if you do any unusual transaction, like let's say you are using your credit card all over West Bengal, but suddenly you went to visit one place, say Goa or Maharashtra, somewhere like that, and you are trying to use your credit card. Immediately before the payment happens, you receive a call from the credit card company that somebody is trying to use this much amount from your credit card. Is it you? Now if you answer yes, then only the payment will take place, otherwise not. Means anything outside the normal behavior you need to identify, and that identification would be helpful for operational activities. So I think I could make you understand this credit card fraud and all these things. Another thing is classifying spam or ham emails. Like this is, though it is actually under classification, but this can also be treated as like whenever an email is received in your box, then whether that email is a spam or ham, that Google or any other email service provider, they actually analyzes it from the content and they place it accordingly into your inbox if it is a ham, and into your spam folder if it is supposed to be, it appears to be a spam. Now these are the types which we can categorize, that what type of studies we can carry out given the data set. Okay, I am sure that many of you have a clear-cut objective of your study, and you can attach your objective to any of these types, and you can carry out the analysis. And it is not that only one type of analysis can be carried out in each type of categories that I mentioned. And these are not only the types of categories that can be done, but broadly these are the types which we mainly carry out when we have the data. Okay, so now if you have any question, please go ahead up to this. Though we did not start anything regarding SPSS, but here we are kind of talking generally that when we are given a data, what type of studies we can perform with that data. I hope there is no question. Now coming back to this particular topic of this workshop, basically we wish to conduct those analysis or statistical analysis using IBM SPSS. Now we all know that SPSS actually started operating back in 1960s, and at that time it was not owned by IBM. Actually, it has some very excellent features, like it's a menu driven software where you do not have to write the code actually, but if you need any sophisticated analysis which is not available in SPSS, you can also write the code. There are provisions, but normally for general purpose we do not need to go that far. So primarily we can say it's a menu driven software. That means we can find the menu for the particular analysis and we can select the variable and we can click and we can get the results. That basically makes it very user friendly. Okay, it's Excel we all use, so it's simple, very simple, and more or less that type. Now once the data are collected, then this SPSS is generally used for analyzing the data. Okay, now how to analyze the data and all those things we don't discuss here, but generally as you have came across probably in your research questionnaire or any other planning part, that this data type may be of different data or variables can be of different types, like what is the response format. Sometimes we get response through yes or no. Are you literate? Yes. Are you literate? No. This could be did you have heart attack? No. Did you have heart attack? Yes. So this can be a 0-1 type response. Sometimes what is your blood sugar level, what is your weight, what is your age. These are actually again some measuramental observations. So basically we have very specific types of variable we need to work on. Now variables are again of different types, say discrete and continuous. I hope you all know what is discrete and what is not. And then categorical also, like which we call as qualitative character or attributes, where it is not exactly the measurement, but it is actually type. Let's say education, level of education can be defined two ways. One is what is your level of education, primary, secondary, university. That is categorized response. And it could be how many years education do you have, did you have. In Western countries, this is one typical type, how many years. So 10 years, 5 years, 6 years, and so on. Now accordingly the nature of the variable changes. Sometimes gender and all those things are also of interest. Now in this categorical variable we also have order sometimes, like when you ask people to rate a particular product in 5-point scale, say very good, good, okay, bad, very bad, something like that. So there is an order. Okay, there is an order, and that type of data are called ordinal. And when it is say there is no order, then we say it is a nominal data or numerical. Now, as I just mentioned, some examples of qualitative data, good, excellent, poor, and we can how to put the data in Excel. We can give some kind of code, like good for 1 for good, 2 for excellent, 4 for 3, and we can reverse them as well, like good for 3, 3 for good, and 1 for excellent, and 2 for poor. That is also possible. So it depends on how you actually design this one. I guess my internet is. Hello, can you hear me? Can you confirm?
Yes, sir, we can hear you. Yes.
Okay. Actually, it was showing some signal that my internet is not working. That's why I just got curious. Anyway, thank you. Now, similarly, male, female. So these are all categories which we can give a code name, a code number, and then we can put the data in SPSS, which you perhaps already were introduced to. Now, numerical data, as I just mentioned few minutes back, average monthly income, marks in examinations, social sector expenditure, and all those things are numerical nature, or you can say continuous variable, discrete variable, number of children. It is numerical again, but number of children in a family, it's a discrete data, like discrete variable which takes its values within its range, but no, those values are not taken continuously, but some isolated points it takes. Now, scales in SPSS, I just mentioned nominal, ordinal, and scale. These are the three types, and I gave some examples, as this is again second day of SPSS, so I think there is nothing wrong in repeating these things. Like when we say what is your gender, sometimes question format, then people answer male, female, and open-ended question also you can say what is your gender. So sometimes what happens is you can give the options to the responder, like what tick on the gender, male, female, third gender, or you may ask the question so that the responder would write. Now, what is the advantages of this fixed response? Easy to enter in your system in SPSS. Now, open-ended question, it is easy to construct, but it is difficult to enter the valid. I mean, sometimes people answers in invalid way. If you say what is your gender, sometimes people may write say A. You do not have any way to incorporate that one. But if you specify the answer like male, female, transgender, then it is likely that the respondent will tick any one of those. So, but the cons of that fixed response type is difficult to construct. So these are actually, when you are planning your study, when you are fixing your objective, then also you have to design your questionnaire or your response variables accordingly, so that you can get the desired data you are wishing to get. Now, as we started talking about SPSS, so SPSS initially it was named Statistical Package for Social Sciences. Now, eventually through different business processes, it is now owned by IBM since 2009, and SPSS itself became a brand actually. That's why it is now IBM SPSS. They never dropped the name SPSS itself. Now, if you open the SPSS interface, which we'll be doing just short while from now, and many of you actually work in that, and so you know this, we have two interfaces. One is data view, another is variable view. Now, data view is a place where you can enter the data, where we have columns and rows, and rows are actually the observation numbers, and columns are actually variables. We should consider it like that. Now, in the variable name, in the variable view, what we get is actually we have to place the names of the variable, and then we can get the list of all the variables, and we also give the nature of the variable, that is whether it is a nominal, ordinal, or scale or something like that. And labels also, like as I mentioned, male 1, female 2, those labels can also be tagged in this variable view. So the first data view, you are putting the information, and the second, you are actually organizing them, or you are giving their actual identity, their nature, their name, and their levels, if any, and so on. Okay, that is, you can say, data description. As I just mentioned, sometimes that we can code different responses. There are some examples. I think this is this may be skipped. There is no need to it. Okay, here there is one data which I should talk on. This is a fictitious data. I just made it for actually demonstration purpose. You see there are some columns, 1, 2, 3, 4, 5, 6, 7, 8, 9 columns in this. I hope all of you can see this, though the prints are not that much prominent because it is a snapshot. You see, first column is ID number, second column is duration of hospital stay, third column is age, and then gender. One is male, two is female. Then it is first temperature, means when the patient is getting admitted in the hospital, then what was the temperature reading of that patient. And then first WBC count, which we, so WBC count, and then whether antibiotic was given or not. One is yes, two is no. And then received bacterial culture or not. One is yes, two is no. And service, that is medicinal service or surgical service. So this is a data where we see different types of variables are there. Some variables are there which are numeric, some are there which are categorical in nature. Though here in any of the categories we don't see any order, so those are simply nominal data like gender, male, female, there is no order. Similarly, antibiotic received or not, this is also nominal, yes or no. And bacterial culture received or not, this is also yes or no. And service type, medical or medicinal or surgical, that is also there is no order in it. So those are categorical variables. Most of them have two levels or two types. And here is duration of stay, age, and first temperature, WBC count. All those are numerical in nature, or we can say continuous type. Obviously, this duration of stay is not continuous type. This is a discrete type. So this is a typical data set you might be having. But you see, one thing I must give you one caution in this, that don't think that whenever you get a data, if you collect it, most of the time it should be more or less cleaned. But generally what happens is, a data generally is not ready to be analyzed, no matter how you received it, either through download or through a personal interview or something like that, because there will be some questions where people will not answer. There will be some places where you won't get information and so on. So missing values will be there. So this thing I must tell you before I go into this technical detail of how to do the analysis, that whenever a data set is received, we must go through a rigorous data cleaning process. That is, we have to make the data ready to be analyzed. Let me give you one analogy on this. Let's say when we go to vegetable market, we bring the vegetables, and immediately after bringing them, we don't put them into the pan for cooking. Do we? No. Why? Because we take for each of the items the best part of it and get rid of the part which is actually rotten or which is not useful. This is called cleaning of the data. So this is called, and for the data also it is something like that. The data might be having missing observations, data might be having outliers, data might be having some extreme values, data might be having some unacceptable values. So you have to deal all these things first, and then you can make it ready to be analyzed. Then this is again a big challenge, and you may be surprised, you may get surprised to know that 70% of the time of a data scientist goes away just to clean a data to make it ready to be analyzed. So this is very important nowadays. It's data are generated everywhere, and we have to take care of this. Now regarding this, like missing plot analysis, also in SPSS, it happens very nicely. And you can, so that I am not talking about right away, but we have to keep these things in mind, that before we start analysis, we should go for cleansing of the data. Now, in the variable view, as I said, we get name, type, whether numeric or not, level, values, that is codes of the answers, measurable, level of measurement. Now, this is a snapshot. I think this may not be identical for all of you who are using SPSS, because it slightly varies from version to version. I guess this one is an older version snapshot. Like I'm using SPSS since it was version 9, and I guess now it is the 29th version is running. But more or less things are similar. Some new features have been added. So this is not very uh, difficult to tally with your editor what you are receiving at your, or with what you see when you open your SPSS. So this is a typical SPSS editor where you put the data and you see this is data view and this is variable view. Now here, as I mentioned, these are the rows, that is number of cases or the observations, and here very I think those are AG, but actually VAR. So actually variable 1, variable 2, and so on. So in columns, the variables will be there, and in rows, the numbers or observations will be there. And so when you are in the variable view, you will see the name of the variable, then type, whether it is numeric or string. String means, as I mentioned, kind of categorical, and then description of the variable, that is I think this cell may not be not here, so levels, and yeah, this level will be the description, and then type, and then this is here you get the variable view. We will be coming there on real time. Now when we enter actually the variables, then actually it depends on the questionnaire, that is the names of the variable and so on. As I mentioned in the example, that levels, we are giving value 1 for level male and value 2 for level female, then those can be added. So we'll be doing it in reality, and so you should be able to understand that. So when we put that data in SPSS, we get a view like this. Okay, so this is the variable view. You see ID, DOHS, duration of hospital stay, age, gender, temperature, WBC count, and so on. Now, if so, you can put this data by typing in the SPSS editor. That is the first part. Or you can save the data in your Excel file and you can import that file from Excel, which is the normal way to do. Because what happens is Excel format or CSV format, which is also saved in Excel, that type of data is generally accepted by all softwares like R, Python, SPSS, Minitab, everybody. So what happens is generally most of the time data are being saved in Excel or CSV format. So if your data is in CSV format, how to bring that one into your SPSS editor? So when you open the SPSS, you click on the SPSS editor, you click on the open and then go to data, and then select, and then automatically it will be showing you the files, and then you select the desired file and click OK. All those things you can follow the screen instructions or screen options, and then you can get to this. Now there are some dialogues which will be like read variable names from the first row of data. Means what happens is whenever a data is saved in Excel or any kind of say CSV, so what happens, the first row is actually the names of the variable. So by default SPSS take that, but whenever the file does not contain it, make sure that you uncheck this dialog box. But generally it is the case, so most of the time we do not have to pay attention to this, but we have to be careful about these things at the time of importing the data in your SPSS interface. Now see, the data is brought here, and then we can save it by going to file and save as, and then you give a name and it is .sav. the extension it gets, and it is done, then done. So it also shows visible 9 of 9 variables. So that is some statistics they are talking about. So it is how you can bring the data into your SPSS. Now, once the data is there, you can do very simple statistics like case summaries, frequency, descriptive statistics, and all those which we will be discussing with the real data, that same data which I just talked about few minutes from now. But before we start the analysis, we have to go to the variable view and we have to give the proper description of each of the variable. Okay. Now, what type of analysis we can carry out? As I mentioned, it depends on your intention or objective. We can start frequency table. We can compute cross tabs like preparing the contingency table for testing the independence of two categories and different other variables. So it depends on your intention. We'll come to that. Graphs also, as we mentioned, that this descriptive statistics can also be expressed through graphs, different types of graphs. It is not limited to these lists like bar chart, pie chart, histogram, line, box plot. And again, you must be knowing that what type of plot can be done for what type of variable. That is also very much important. Like for a categorical variable, pie chart is fine. Like, okay, out of 100 people, how many are male and how many are female? If you express that through number, it will be difficult to understand. But if you express that through pie chart, then an illiterate person also can understand that, okay, what proportion of people are male and what proportion of people are female. So like that, histogram can be done for a quantitative data of continuous variable like marks in an exam. So like that, you have to be very specific about the nature of the variable to carry out a type of analysis. So I would say it is more understanding the data and nature of it, and then finding out the type of analysis you do, and then it comes about the software or the means how we are going to perform the analysis. Okay. Now, as I mentioned, like when we have the data, so let's say we have the data and we are going to generate some reports. Means kind of descriptive type of statistics. So simply, as I mentioned, it's a menu driven software. So you click on the analyze, then click on reports, then case summaries. If you click here, and then you get some output, and then you can interpret accordingly. But these are very simple stuff I am talking about. We'll be doing with a real data set. Now here one point we would like to mention, that when you are having the output, it is in a different window actually, and you have to save if you need. Then if you wish to, then you have to save that output file separately. Like if you think that I have saved the data file, that means whatever analysis I am doing, it is getting automatically saved. No. If you come out by mistake by crossing, it would ask to save the output file. If by mistake, if you do not click OK, the output file will get deleted. Okay. So these things, so whatever chart, whatever table, anything you can do, you have to be careful about saving those before you put those into close. Now, how does the case summary looks like? Like you see, as I just mentioned, when I carried out this one, we get this one, like case processing summaries. So these are the variable names, how many observations are there, n is number of observations, then how many percentage of data are included in this 100%, because there was no missing. Now excluded 0%, and total this one. So this is actually, it says that how many observations are taken for analysis in SPSS. Now again, it is actually showing the entire data set. Obviously some additional feature, it is showing minimum, maximum of each variable. So DOHS minimum is 3, maximum is 30. For age, minimum is 4, maximum is 82, and so on. Okay, so this is as if it is showing the entire data set. If you have more than 25 observation, then it will be not saving in a single window, it will be longer one, and so on. So those stuff is not difficult to follow. Okay, now let's say we are done with the data saving and no missing value is there. We have actually incorporated whatever cleansing process should be carried out, and we are now ready to be to analyze the data. Now, first of all, if we are interested in finding the descriptive statistics like mean, variance, median, quantile, first quantile, second to quantile, third quantile, and so on, how to carry out those using SPSS. So this is the dialog box. You have to click on this analyze, then you have to select this descriptive statistics, and then again, whenever you click here, you get many options. So it depends on what type of analysis you are wishing to have. Okay, so you select that, like here we are doing analyze descriptive statistics, and I think it is descriptives only, descriptives. Then what dialog box comes? This one comes after that. It is actually what are the variables for which you wish to have the descriptive statistics. It will show in this left box all the available variables in the data set. Now, if since ID is the variable which we are not interested in, we are interested in all other variables like duration of hospital stay, age, temperature, and WBC. So we have selected all of them in a single go. It's very simple to do. You click on one variable and press the shift button, and pressing the shift button, you click on the lower arrow and all the variables will be selected. Once those variables are selected, then you will see this arrow will get into live. And you click here, all these variables will be coming to this box. That means you are wishing to have descriptive statistics on these variables. And as soon as these variables are transferred here, this OK option here, which is not yet came into life, it will come into life, and you click OK, you should get the results. In fact, you can give some other options as well, which will be showing after some time. So this is how you are going to get. You see, this is the next screenshot. That means the variables are transferred here, and you see immediately this OK button came into life. You see, earlier it was not. As long as these variables were here, this OK button was not in life. So you cannot do this. But once you transfer these into this box, then it should show you this option. And yeah, now how did this one came? As I said, you can click OK, but you can also exercise some options. So after you bring those variables here, you click on this option, and then the options are showing here. That means mean, what are the statistics you are wishing to have, like mean, standard deviation, then minimum, maximum, variance. If you wish, you can select sum, standard error of mean, and so many things. I just selected these things and then continue, and then OK. Once I click the OK, I should get this particular output, where you get the duration of stay, number of observations 25. Now range, what is the range? We all know what is the range. It is maximum observation, maximum value of the observation minus minimum value of the observation. So max minus min is the range, which is written here. Minimum is written here, maximum is written here, mean is written here, standard deviation is also written here, skewness, and then kurtosis, all are written here. And standard error and all those things, I hope you know what those things are. So you see, whatever we need, we get these things just by selecting the appropriate variable and giving appropriate options and So everything comes over by clicking. So that is why it is user friendly. In other softwares like R, you would get also very simply just by typing a command SUMMA and name of the variables or name of the data file, you should get all this. So obviously it depends on the choice which type of software you are using to have. But anyway, since we are discussing SPSS, so that is how we can get the descriptive statistics like this. It is very simple, and I am sure you can do it at the first go. And since many of you are using it, you do this all the time. So now, so the analysis I showed just now was for numerical variables. But what if we have a qualitative variables like gender, we had this what type of treatment the patient received, and so on. Those things we should be doing using cross tabs. So again, analyze, descriptive statistics, and cross tabs. So I have given the flow of the selection like analyze, descriptive statistics, and cross tabs. Okay. Now you select those. Again, you will have the same type of options like what are the variables you are going to have. So you see, I have taken two. One is gender, another is antibiotic received or not. That means I am wishing to know that whether antibiotic reception is gender biased or not, or whether antibiotic reception is depending on gender or not. So for that, we are going to construct a 2x2 contingency table where we would have a desired frequency distribution of different types of gender and the antibiotic received or not. Okay, we'll see that in the next slide, I guess. So it is again analyze, descriptive statistics, and cross tabs. This is useful for qualitative variables. And click on the OK. You see, we got this 2x2 contingency table. So it is gender cross and received antibiotic cross tabulation. Means received antibiotic, 1 means yes, 2 means no. Gender male, female. So out of 11 males, 5 males received antibiotic and 6 males did not. Similarly, out of 14 females, 2 females received antibiotic and 12 did not. Similarly, out of 7 patients who received antibiotics, 5 are male and 2 are female. And out of 18 patients who did not receive antibiotics, 6 are male and 12 are female. So looks like that as if males are more prone to get be given antibiotic. So this type of conclusion may be drawn just superficially without conducting any tests or something like that using this type of table. Or you can give this table and you can write an interpretation that it looks like males are more prone to receive antibiotic than females. However, we need to get that tested using standard statistical tests. Now, then you carry out the test and then you put that interpretation, and that will actually elevate the standard of your thesis or your report, so that you are not doing an analysis just for doing the analysis. You are doing the analysis as the sequence says to do that. That has to be very clearly understood. So now if I had the question, like as I mentioned, that whether gender biased and then antibiotic reception, there are some standard tests which you may be getting taught in this course. So for that particular test, are they independent? That is gender and antibiotic reception. For that, there is a chi-square test. When we carried out this test, we got this test statistic value 2.968, and this significance level and everything is there. Now since this p-value is 0.08, that means at 5% level of significance, we are going to conclude that no, it is not gender biased. They are not independent. So sorry, they are independent, because if this significance would have been less than 0.05, we would have decided at 5% level of significance that yes, they are independent. Now coming to our discussion of correlation and regression. Now, before I go here, I must ask you some of the questions because I am talking so much since last 30 or 40 minutes. Now, I must ask you some questions if you have any doubt or not before I move to the correlation part. Is it okay?
Hello.
Yeah, please.
So could you please explain the chi-square test that you have applied and the values which we actually denotes the significance level and degree of freedom, each and everything?
Yeah, those things is actually not under today's topic. I hope I have another session on day after tomorrow, so we can discuss that on that day. Okay, so don't think that I am not going to discuss it now. Discuss it. I will be, but in the next day. And I hope there is one session on parametric inference, maybe today or tomorrow. So there also, I think those things will be discussed. If not, then on my session in the next Thursday, I will be definitely covering those parts. I would like to discuss the much simpler things before going to the complex one. Is that okay?
Okay, sir. Thank you.
So okay, before I move on to correlation regression, I hope most of you actually know what those things are. But I will be making a very quick recapitulation of that, and then we'll be doing that in SPSS. So does it sound okay, whatever so far what I have mentioned or what I said, or I need to change the pattern or how I'm running the show?
No, sir, it's okay.
Okay, thank you very much for your feedback. I hope, and sometimes what happens is, though it is not okay, we participants generally don't come forward to say it anyway. So I assume this is fine. Now I will be quickly discussing about correlation and regression, and which I hope all of you know. Okay, is there? I know Amartya is from statistics. How many are there from statistics? I did not came across anybody during the introduction. Is there anybody from statistics other than Amartya? I guess no. Anyway, so this is something which we must. So what happens is most of the time people starts analyzing or using softwares without knowing the thing, and where they get stuck is in interpretation. So one very dangerous thing about software is you give something, it will give some output, but you have to give it properly, and when you give it properly, then only you get proper result and you can interpret it properly. But if you do not understand the underlying sequence or the logic, then it is sometimes very difficult to carry out the analysis. Now, just since many of you are not from statistics, I just would recapitulate the correlation and regression very quickly, and then we'll be coming to the SPSS hands-on. Now, what is correlation? To simply speak, if we say that if two variables are such that the changes in values of one variable results changes in values of the other variable, then the variables are called correlated. Means one is causing change in the other. If the situation is like that, then we say the variables are correlated. We can give some example, very simple examples. Duration of study and marks in exam. Though we can disregard the extreme issues, but it is normally what happens is when somebody studies more, gets higher score in the exam, right? So it is the duration of study, which obviously intellectuality and other merits and everything are there, but generally what happens is who studies more, they get more marks in the exam. So these two variables, the duration of study and marks in examinations, are correlated. Similarly, rise in temperature and sales of AC machines. What happens is when temperature rises, the sales of AC machines also increases. Decreasing temperature and sales of room heaters. Here the things is opposite. When temperature decreases and sales of room heaters decreases. When temperature decreases, room heater sales increases, and when temperature increases, room heater sales decreases. So this is negative correlation. Number of schools and number of higher secondary qualified students. So these are the scenarios where we can understand which variable is affecting the other one. Okay, so this type of pair of variables we call they are correlated. Now obviously there are different types of correlation. One is positive, one is negative, another is independent. So in this type of situation we have to be very careful about the causality. Means the cause effect scenario must be there, otherwise we cannot call the variables are correlated, because as I said, anything you give in the formula it should give a result, but that does not mean that the variables are correlated. The cause effect relation must be there. So in these two variables, one should be cause, that is independent variable, and the other should be effect, that is the dependent variable. Like exam and duration of study, the duration of study is the independent variable and result is the dependent variable. So when the movement of both the variables are in the same direction, then we say the variables are positively correlated. When movement of both the variables are in opposite direction, then they are negatively correlated. Here are the examples. Duration of study, marks in exam, positive. Increase in temperature, sales in estimations, positive. Number of schools, number of higher secondary qualified students, positive. Number of deep tube wells and groundwater level, negative. Increase in temperature, sales of room heaters, negative. I hope you now have the basic idea of correlation. Now, how to detect that? First of all, once we get the data, and supposing the data do not have any kind of issues like missing values, absurd values, and so on. For detection of correlation, what you do is you plot those data, raw data, into a two-dimensional plane, while in the x-axis or in the horizontal axis, the independent variable will be placed, and in the vertical axis, the dependent variable will be placed. And the plot we get is called scatter plot. We can get a plot like this, where we would say if we have this type of scatter plot, our interpretation would be the variables are not correlated. Because here you see, you cannot see any pattern, right? But if you see that the second one here, you see as the values in this variable increases, the value in the y-axis decreases. So here it is negatively correlated, right? So this is very simple but very informative. Similarly, this one is positively correlated because values in this variable increases and values in this variable decreases, increases. So this is positive correlation. Now this one is very important, related but not linear. You don't think that the type here we are showing are the only type we can have. Now the correlation we mention here, generally we mean here linear correlation, means that they are linearly related. But what happens is there could be some other type of relationship like y equal to x squared. X is the independent variable. So in that case, we would get a graph like this, or some other curvature type of pattern should be there. Okay, so here our conclusion would be related but not linearly related. Okay, now measuring the extent of linear relationship, as I mentioned, generally we talk about initial.
Sir, could you please tell can you give example related but not linear? The previous slide.
Yeah, I can give. I just gave you. Okay, let me just say this. Let's say x equal to -2, -1, 0, then 1 and 2, and y equal to 4, 2, 1, and 0, 2, 4. I think I have this example. Let me go ahead and then tell. And if you compute the correlation coefficient in this particular data which I just spoke about, then you would get correlation coefficient is 0. But here is exactly curvilinear relationship, because y equal to x square, because I said x equal to -2, y equal to 4, x equal to -1, y equal to 1, x equal to 0, y equal to 0, x equal to 1, y equal to 1, x equal to 2, y equal to 4. So you see here directly y equal to x square, but if you compute the correlation coefficient with the formula which we are just going to show you, then you would get 0, the value 0. That does not mean that the variables are uncorrelated. It means whenever you get r equal to 0, don't immediately conclude that variables are not related, but you conclude the variables are not linearly related. This should be very clearly understood. I hope this example is there. I'll be showing you. Now, to measure the extent of linear relationship, initially if we see the variables are linearly related, then we have to measure the extent of linearity. That is how strong the linear relationship is. And that formula is given by this one, covariance of x1 by sx into sy, where sx, sy are the standard deviation of x and standard deviation of y. Those who are not from statistics, for them I can tell you this is the simplified formula, and this much you have to definitely understand that this particular formula can be derived into this simplified one. And when you have a pair of n observations of xi, yi, then you can put these values and you get the correlation coefficient value. Okay, now there are some properties. I'm just going to simply state those properties which are very important to know. Don't keep those in mind, but some concepts must be there for interpretation. Like correlation coefficient between x and y are symmetric, that is rxy equal to ryx. Then correlation coefficient lies between -1 to +1. This is very important because you gave something in this formula and you got something 2.5 and you said that this is a correlation coefficient. No, you have to check that whether this is within the range or not. -1. This is unit free, means it does not have any unit, semi, kg, millimeter, no. And how that is how it is designed. And I am skipping these two because this may be difficult to follow right away, but these are for actually computing the correlation coefficient in an easier way, that is change of scale and base. And those we don't need because when we are computing using computers, so we don't worry about the computational effort. Now I think I have mentioned this one. Now regression, as I mentioned. Okay, so I just give you one thing here, as probably I don't see that example, as somebody asked me to give an example. So you put the data I just spoke about. I will just show you in the Excel and in the SPSS. So no need to worry about that. That when R is 0, but they are perfectly linear, perfectly related. So just remind me if I forget during the hands-on. Now coming to the regression means when we found that the variables are linearly related, that means if y is the dependent variable, then we can say y equal to a plus bx, where a is the intercept and b is the slope. Now linear relationship can be written as like this: y equal to beta naught plus beta 1 xi plus epsilon I. Now what is beta naught and what is beta 1? This is actually slope and this is intercept. Now this is the independent variable and this is the dependent variable. The benefit of this is, if you put, let's say this is weight and this is height. Now if you know this beta naught and beta 1, and if you put one value of x, you would get the value of y. That is actually the intention. This is called predictive analysis. Means we establish that these y and x variables are correlated and they are linearly related. So let us express the y, the dependent variable, in terms of x, so that given the value of x, we can estimate the value of y for practical purposes. Like you are given the last 10 years population of particular district, and you are asked by your supervisor or somebody else that you tell me what will be the population or expected population in next 2 years. Okay, so you have to do that. Now what does this epsilon do? I am not going to technical detail of this, but I am saying this: the relationship here we are mentioning is not exact in nature. There would be some error. That is why this epsilon is there. Now if you get confused that what does that mean, exact relationship, let me tell you that there are some physical laws where the relationships are exact. Perhaps many of you have studied Boyle's law, Charles' law in your earlier studies, or at least Newton's law of motion in your 10th level or 9th level. So there we found one equation, let's say P equal to mf. P is the force, m is the mass, and f is the acceleration. P equal to mf. Those relationships are exact in nature. There is no error. PV equal to RT. This is also one chemical equation from chemistry, or say Ohm's law. So those things are, those relationships are exact in nature. Like the equation of pendulums, that I mean periodicity of a pendulum, T equal to 1 by L. L is the length of the pendulum. So I am not going to detail of that, but what I am trying to mention here is that the statistical relationship are not exact in nature. Those are with error. That is why this epsilon is there. And if those were exact, then there was no need of statistically estimating this. Let me give you one more example. Let's say today you are of age 30. Now what will be your age after 5 years? Exactly 35, because 30 plus 5 is 5 years, 35. But if I say today your weight is say 55 kilo, what will be your weight after 5 years? You cannot say that. Exactly, we cannot say that. You can estimate that. That is the difference between exact relationship and statistical relationship. So that is why this epsilon is there. Our intention always be to estimate this beta naught and beta 1, that is to give the value of this beta naught and beta 1, show that error is minimum. The error is minimum. And how do we do that? By previous values. Generally what we have is, we have n number of observations on x and y, and we have to derive this relationship. How do we derive that? There is some least square method and so on. I am not going to detail of that, but out of that method what we get is, so this is actually when we are estimating y, these are the errors. So this line, this red line is this line. So when the value of x is this, the line is saying the value of y is this, but the actual value is here. So this is the error. We have to estimate beta n and beta 1 in such a way that this error sum of squares will be minimum. Now, see, as I mentioned, this is one error and so on. Okay. So this is ensured by minimizing the sum of least squares and predicting the thing. So you don't get confused with that. Now, these are the mathematical formulas, how those are being calculated, and I'm not going to detail of this. But you see, given a data set, after we solve all these equations, we get a result like this. So weight equal to 80 plus 2 into height. So once you give somebody's height, we can estimate the weight, and that is actually the fitted value of these constants. Okay. Now there are two types. One is y on x, another is x on y. I am not going to explain that any further, because actually when y is dependent, then we are calculating the vertical errors, and when x is dependent, then we are calculating the horizontal errors. So this is y on x, y equal to ab, and this one is x on y. You see this is here, x is the dependent and y is the independent. When x is estimated, then we are calculating this horizontal errors, minimizing this horizontal error sum of squares, and this is when y is dependent. Now this is already I mentioned. So these are the things we should keep in our mind. Now if I go to this Excel, not Excel, I'm just sorry. If I just go to this SPSS right now, you see I have just talked about this data, and I have just typed this data. I'll be showing how to open a data file from your saved data files just few minutes from now. You see we have duration of stay in hospital, age, gender, and initial temperature. So this is the data view and this is the variable view. You see the variable view, I have given the name DOHS. It is type numeric with total with H and decimal 2, means after decimal how many digits it should show. If you type here 1, it should show 1. If you type 0, it will not show anything after decimal. Now it is the level of the variable. Now values missing, is there any value? No. How many columns it should take? 8. Generally it is by default this. Alignment, you can keep them in the center also. You can change this center. If you now look at this, see these got in centered, but these are actually not in the center. You see these are in the right. So this you can change, so that is fine. Now you said type, scale. Nominal means, as I mentioned, categorical, and this is also scale. Scale means you can say numeric, which is generally measured in a scale. And so this is variable view and this is data view, right? I just typed the data. Okay, let me type one more data here, just for let's say weight. Randomly, I'm putting some values just for your yeah, I guess I have typed everything like this. So it by default it has taken VAR005, but I am not going to change it. So let me give a name weight, just for weight or WP. It is numeric in nature. Now weight, weight of patient, and no label, and this is also okay. If you see how to give the label, Then you see how now there is no label. If I click here, I can give here value label. Let's say 1 for say male. I'm just showing you how to give the label, and we can add one more and say 2 for female, just for showing. So it has taken, and it's if I just now give this nominal, so it has taken as nominal. Just let me. Am I online? Can anybody confirm?
Yes, sir.
Yes, sir.
Okay, okay.
Yes,
Okay.
sir. Yes.
Okay. Okay, so this is how we can give the levels, and I am just eliminating all those. I am just eliminating this one because these are actually weights, and okay, and then this is actually scale. So you see, this is as simple as that to incorporate a data when you are typing the data on the SPSS editor. You see one more thing, what the label does. You bring the cursor where it describes the variable, right? Weight of per patient. So I misspelled it. I should give it weight of patient. Weight of patient. So now you bring it here, you get the description of the weight of patient. Duration of hospital stay. Name of the variable DOHS. It is type numeric. Age. This is also age of patient numeric. So this is the labeling benefit. Now gender. This is gender. It is of type string and nominal. Now, as I was mentioning the type of analysis here, we are not. You see, if there is any missing value, then it will be showing here. Okay, now in SPSS we can do missing value analysis in different way. I'm not going to discuss it right now. So let us start this analysis process. So as I was mentioning that analyze, then initially I was talking about reports. Then so what I did, click on analysis, reports, and then case summaries. And for what of the variables you are, let's say for all the variables. So I have selected one, and then I press the shift button and lower arrow together. So I have selected every one of them and I brought them in this direction. I am bringing back them again. You see, as I was mentioning, that this OK button is not in live now. But as soon as you bring at least one variable in this right corner, right box, then it should be okay, come into life. So you can bring them one after another also. Just for what are the statistics you wish to get. You can also select mean, median, and all those things. Right now we are not selecting here. What are the other options? You can give a caption and all those things. Let it be there and okay. When I'm running okay, you see, as I mentioned, the output is generally generated in a different window, and it should be saved before you close the session. You see, these are the case summaries you got for two variables, weight of patient and duration of hospital stay. So these are all the observations, 25 observations, total number of cases. So these are the cases it has taken into account for the analysis. Now, if we are interested in analyzing descriptive statistics, so analyze, then descriptive, and then here we can do cross tab. For here I have only one gender, so I think I need to give one more. Okay, we'll do that afterwards. So descriptives and then descriptives again. So you see, descriptive statistics we would get for quantitative variable only. So duration of hospital stay we can take, age we can take, initial temperature we can take. You see, gender was not there. So SPSS itself discarded this variable from this list because gender is a string, and for that descriptive statistics does not arise. It will have only the counts. We will be coming to that point as well. So we want descriptive statistics for these variables. Now what are the options available? As I mentioned, you can compute mean, you can see the sum, standard deviation, even variance, even range, and kurtosis, Q-names. Let's say I am looking for everything, whatever options are there. So I can click OK, and I'm not going to discuss this bootstrap and other things. And let's say OK. You see, I got the result immediately in this dialog box. What we got here is, for each of the variable, we have duration of hospital stay, total number of observations 25, range of this 27. I hope you can remember the same result was there when I displayed this in the presentation. Now minimum value, maximum value, sum of the observations, this was not there in my presentation. Mean, standard deviation, variance, this was also not included there. Skewness, kurtosis, and everything for duration, and for the age also. So like that, you can get the descriptive statistics of the variables under study like this. It's very simple. So you have to just go into analyze, then descriptives, and descriptives again, and then select the variables. As those are already selected, we have computed, that's why those are here. And for whatever variable you wish to do this, you bring them in the right hand side box, and okay, it should be done. Okay, now frequency, let me do descriptive statistics and frequencies. You would see this one, you would have gender, and as I bring it here, and let me what are the statistical things it should give, mean, variance, those things does not apply here. Charts, let me pie chart. You see, gender, as I mentioned, for gender we can give chart. So pie chart we can give. Histogram is applicable for quantitative variable of continuous type. And now, okay. You see, I got the frequency table of gender. How many males are there? 11. How many females are there? 14. Percentage also given, and cumulative percentage are also given. And you see, we got the pie chart as well. So we got the males, females are more than male. This is as simple as that. Okay. So this is as simple as that. Let me then compute the correlation coefficient, and then so analyze, and then I want to compute the plot, right? Because I told that for assessing the linearity between the variables, we should look into the scatter plot. So go into this graph, you see. In fact, we can draw the pie chart and other things using graph as well. So here we should go for scatter plot in the way below. Scatter plot. Now there are different types. Let us choose the simple one and define. Define means for what variable at what axis. So age should be, let me bring those as it should be originally. So we were interested in finding the correlation between duration of stay and age. As if those who are older, they are more likely to the hospital. I mean, for them the duration should be more, something like that. So in the x-axis the age, and the y-axis the duration. You see, this can be treated as hours as well. Don't take those are days or something, but anyway, that's fine. Now what are the options? Let's say there is no title you can give. Okay, you can give scatter plot of duration of hospital stay. Duration of hospital stay against age. So continue, and then okay. You see, this is the scatter plot. I'm just muting myself for 1 second. You please bear with me. Okay, so I'm back. So I hope you understood that. How did we get the scatter plot? This is the scatter plot, though we don't see a direct linear pattern here, but somehow we got an idea how the variables are related. Okay, now I will be coming to that question which one of my friend told, that they are related but not linearly. So for that we have to go to analyze. So let's say we got the sense that they are related. Now we have to find the correlation value, correlation coefficient value, using that formula. How to do that? You see, correlate, and then bivariate. Here only two variables are there. So duration of hospital stay, let me bring all those in the left hand side. So we are wishing to get the correlation between duration of hospital stay and age. Okay, what are the options? Let me check. Okay, standard deviations and all those things, style and all those things. Right now, Spearman and Pearson, we are going to compute the Pearson, because the formula I showed you is Pearson correlation coefficient formula. Today we are not going to discuss anything regarding non-parametric thing. Now you see, you click OK. You see we got the correlation coefficient value. What is the correlation coefficient? This is the correlation coefficient. 0.39 is the correlation coefficient. 0.39, and this 25 is the total number of observations. Okay, so we wanted to have the correlation coefficient between duration of hospital stay and age of the patients. So we got it 0.39, which is not a great correlation, because anything near to 1 is high correlation. If it is negative, then also high correlation, but in negative relationship. And if it is positive, then also when it is near to 1, it is high correlation with positive relation. Anyway, now let me construct this regression. So we would go to analyze, and then regression, bivariate, linear, and then linear, and let me bring it here. So here, as I mentioned, we should have a clear-cut idea what is the dependent variable and what is the independent variable. Here, duration of stay is the dependent variable, so I am putting that into the dependent, and say age is the independent variable. For demonstration purpose, we are bringing this into independent variable. Now, what are the plots? We can have different types of plots. Right now, histogram, normal probability plot, all those things I don't want to make this cumbersome to you for understand. And let me give you the simplest thing. So I chose the dependent variable and independent variable, and then clicking the OK. So you get the results immediately here. Now you see, as I mentioned in the regression presentation, that you'd have y equal to a plus b into x. So what is the a and what is the b? Here you see the dependent variable is duration of stay and independent variable is age, right? Now this is the r, which we already have mentioned. R square is 0.152. What does it mean? Let me explain just few minutes from now. and what are the estimated values of coefficients. So it is a constant. This A is 3.966 and B is 0.113. So as I was mentioning that y equal to A plus B into X, so here duration of stay equal to 3.966 plus 0.113 into age of the person. That is the regression equation. Now it is not the end of it. Before we conclude this regression to be used for estimating the duration of hospital stay, we must know whether this regression is actually doing its work nicely. The answer to that is no, it is not. Why? Because if you see this ANOVA table where the significance is 0.054, that is, which is more than 0.05, that means this regression line is 0, that probability is 0.054. That means this regression equation is not going to estimate y, that is estimate duration of hospital stay using the age nicely. One more indicator to that is this R square value. R square is 0.152. If this R square is near to 1, then you'd say the regression is actually going to predict the dependent variable nicely, because this means 0.152 into 100 means 15.2% of the dependent variable variance is explained by the regression equation. What does that mean? Let me say it again. Let's say you have the duration of hospital stay data and you have a variance to that data. Now you are estimating the duration of hospital stay using this regression equation. So it is supposed that the estimation should be as good as possible. Now when the estimates should be good, then the estimate should be true, should be equal, near to the true value. So in that case, the variance of the estimated dependent variable value should be nearly equal to the variance of the original dependent variable values. That means the variance of the estimated values divided by variance of the original values, this ratio should be near to 1. If it is 1, then you'd say the regression equation is actually predicting the dependent variable nicely. But here, this ratio is 0.152. That means 15.2%. Anything below 50% should be totally ignored. If this R square is at least 0.7, we would say the regression equation is doing a good job. Okay, so this is one more thing. And one more thing, I'm not sure how much you could follow, but let me just say that another thing is the significance of the coefficients. Now, as far as the significance of the coefficient is concerned for this particular parameter age, I mean variable age, it is 0.054. Again, that means this regression coefficient is 0, that probability is 0.054. That is quite high, because anything above 0.05 is taken as high in this type of testing. So our conclusion to this regression is we should not go to estimate the duration of hospital stay using age, because these are the reasons. The R square value is way less than 0.07. The regression coefficient, the significance of the regression is 0.054, which is more than 0.05, and the significance of the regression coefficient of the independent variable age is also not statistically significant. Okay, so these are the ways how we can say, and this is again normality dependent variable and its histogram plot. Okay, one thing I should have mentioned earlier, that when we are running a linear regression, we should take some assumptions. Those assumptions are the variables we are dealing with should be normally distributed. Now, those who are not from statistical background, they may be asking this question, how to judge that normality. So there are many ways, but to be very quick in that diagnosis, I would say you plot the histogram of the variables, and if you see this type of plot, a bell-shaped curve which is symmetric in nature, then you can say the variables are normal in their nature. Okay, that is one quicker way to say how the variables are normal, whether the variables are normal or not. Okay, now coming back to this particular question which I just told, that -2, -1, and then 1, no 0, and then 1, 2, and let me tell the values. So this is 4, this is 1, this is 0, this is 1, this is 4. You see, I have taken variable 7 and variable 8. I am going to scatter plot of those. Okay, let me take some more. Okay, let me take some more here. So -3, -4, -5, and +3, +4, +5, and here it will be 9, and then 16, then 25, then 9, then 16, then 25 again. So I am going to plot the graph of these two variables define. So variable 7 would be in this. Okay, let me erase those. So variable 7 in the x-axis and variable 8 in the y-axis. Okay, now okay, and you see what is the scatter plot, not this one. You see, this is the scatter plot. You see, this is not a linear relationship, right? Did you get my point? This point I raised, and somebody asked for this calculation I just now showed you. You see, this is not a linear relationship, a perfect curvilinear relationship is there. Now, if we compute the correlation coefficient between these two variables, let us compute that, analyze and correlate, and then bivariate. What are the variables? Let me take those two into this box, and let me take these two into this box. Okay, and you see what are the values. See, the correlation coefficient value is 0. Pearson correlation coefficient is 0. Okay, but you see, now you look at the nature, you see these values are nothing but, actually let me change this one, that is also not going to change anything. So actually if you look at this, -2, 4, that is square of this is this one, 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 square of this is this one. Therefore, though we see that there is a perfect relationship, but the Pearson product movement correlation coefficient shows us that they are not related. So that is why you should not momentarily conclude that the variables are not correlated by looking at the correlation coefficient only. You can conclude if the correlation Pearson moment correlation coefficient is 0, you should conclude that the variables are not linearly related. However, there may be some other type of relationship. Okay, one more quick point, like here I have just mentioned a bivariate linear regression, but it can be multivariate as well. Means dependent variable is 1 and independent variable is more than 1. Let me give you one example. Let's say paddy production. It depends on temperature, it depends on rainfall, it depends on manure used. So 3-4 variables are independent and 1 is dependent. So if this is the scenario, then a quick way how to compute the linear relationship, let me show you. So you go to analyze, regression, and then as I just mentioned, linear, and then here duration of stay is the dependent variable, and independent, as I already mentioned, age. Let me take the weight also, weight of the patient also. Okay, let's say this one as well, initial temperature. Now you see, now two independent variables are taken here. You run this one, you should get the results here. And now you see that here the significance came down, means here the regression equation is y equal to a naught plus say 0.162 into age plus 3.337 into initial temperature. Means যার initial temperature বেশি ছিল সে মানে তার ডিউরেশন বেশি হচ্ছে, কারণ কোরিলেশন গুলো সব পজিটিভ এসছে। আচ্ছা, so this is the regression equation and significance is less than 0.05. So at 5% level of significance, this regression is significant. That means we can say that duration of stay can be linearly estimated using two variables, age and initial temperature, where the equation would be duration of stay equal to minus 326.018 plus 0.162 into age plus 3.337 into initial temperature. Okay, now this is, I would say, not a perfect linear regression or something like that, but this is actually, I could show you how you can carry out a linear regression of bivariate type and a linear regression of multivariate type using SPSS, how to check the correlation, how to find the scatter plot, and other stuff as well. Now I think my time is over and I should stop now. If you have any questions, please go ahead. And
So I wanted to ask you that for regression, like you said that the data should be normally distributed. Does the same apply even for correlation?
no, not for correlation. There is no such assumption is needed. You see, I mean, the least square method on which the constants of the regressions are estimated, that needs those assumptions. And you may be asking that if that does not follow, then what is the solution? So for that we go for non-parametric way, and another way is that we can take transformation of the observations to make it normal. There are different types of transformation, like taking log transformation or taking some linear transformation, which makes the data normal. Perhaps I do not have the time, otherwise I would have showed you one data which is a real data on Airbnb, where I was just teaching on the other day in the class, and I found that the data was not normal, and as soon as we took a transformation, it became normal. So when you are going to find the regression equation, then you must check the normality of the variables associated with the regression.
Thank you, sir.
Okay, anything else?